So I will start, and I apologise if this is too simple or not. I wasn't 100% sure of the audience, so I've started really easy, and you probably all nod and go, I already know this. But if you don't, hopefully it's of value. I'm going to talk a little bit about where I see the current industry, the mining industry as a whole, and then my limited understanding of Peru. And I'd like to think that you probably all know so much more than me, so you can call me out and say I'm wrong. And then I'll talk a little bit about Bechtel and what we're doing and how we're approaching decarbonisation, both from our internal processes and also how we're assisting our customers. So this is the easy stuff that you probably already know. I'll start with the most basic of terms. You've probably heard these before, but if you don't understand them, Scope 1, Scope 2 and Scope 3 emissions. It's quite an easy term to understand, but I think some people hear these things and actually don't understand fundamentally what they are. So most basic one, Scope 1 emissions are things that you directly burn or you directly emit on your site. So easiest way of thinking of this is pour diesel into your truck, you burn diesel, the emissions from the truck, Scope 1, they're your emissions, you're burning them. Scope 2 emissions are they're indirect emissions, but they're within your control. So they're your primarily electricity. It also includes things like steam, if you're purchasing steam or other energy sources, but most of us for mining, it's electricity. Scope 1 and Scope 2 are sort of the bottom layers, and they're the simple ones to get. And Scope 3 is value chain emissions. These are a bit more abstract because everyone interprets Scope 3 emissions a little differently, and there's no, at this point in time, the reporting requirements are a bit open-ended for Scope 3, but they include the value chain prior to your operations and post your operation, so upstream and downstream. The upstream emissions are typically things like purchasing materials, transport of materials to site, moving people to and from site. And the downstream, which is usually the big hit for most of the mining companies, is use of your material or use of products sold. And I'll share some statistics later, but anyone that mines iron ore or bauxite has a very large Scope 3 footprint because of the downstream refining and smelting. Sorry, make sure I get my notes correct. The next one is CO2e. Again, probably all heard this, but everyone says carbon, and carbon's probably the biggest one and the easiest one to talk about, but CO2e is a normalized carbon. So there are multiple gases that cause global warming effect, and they all have a different level of global warming effect. But CO2e is the normalization of all of those gases to a common unit of carbon. The ones that you probably see most often are methane and the nitrous oxides. They have multipliers of about 25 and about 300 times more potent than carbon, but they're emitted in far smaller quantities. So I'll use my diesel example again. A litre of diesel, if you burn it, produces about 2.7 kilograms of carbon dioxide. I'm going to get my numbers wrong because they're so small. 0.00 or I think it's about 2.3 by 10 to the negative 5 of both the nitrous oxides and methane. When you multiply those by the global warming potential, they have an impact of about 0.5%. So carbon, 99.5, and the other gas is about 0.5. Obviously, again, I can't imagine there are many coal miners in the room, but coal miners, methane's a very big problem. Obviously, the atmospheric emissions from methane, just purely by mining, are very large. Then there are other gases which are, again, smaller but have a much larger footprint. So sulfur, hexafluoride, the hydrofluorocarbons, and PFCs, probably more apparent in the aluminium industry than others, but they have very large footprints, but relatively small emission quantities. Another term that you may or may not have heard is the GHG protocol. That's a group set up about 20 years ago, and it's sort of become norm for how people estimate and account for carbon emissions. I think it's something like 92%, 93% of companies follow the GHG protocol method. So we do as well. And it's just I guess an easy way to follow a standard. It's not like an accounting standard where it's mandated, but at least it's heading in that direction where we can all talk the same talk and use the same methodologies for estimating carbon emissions. There are other accounting standards, but I'm not going to those because the GHG protocol is almost the norm that we all use. So big picture, what's the mining industry's footprint? If you count scope 1, scope 2 and scope 3, it's around 12% of global emissions come from mining. So we cast a long shadow is the position there. If you look at that scale there, it's got the mining, the refining and smelting processes. So ultimately, I haven't called those scope 1, scope 2 and scope 3 because it depends on the company's footprint. So some companies have downstream processing and some just the mining. But what stands out quite starkly is aluminium industry and the iron ore and steel industries. Obviously, very, very large. Iron and steel, somewhere around 7% of global emissions. And then the others sort of look like a little sliver across the bottom of the graph. Again, I don't expect there's probably many iron ore miners in here, but when we talk to iron ore mining companies, scope 3 is a massive deal because of obviously they're so associated with downstream processing. And any of the changes to the downstream processing has potentially an upstream impact on their product. So we're starting to see some input from the iron ore miners that are really pushing hard into what technologies they can develop in the steelmaking space. I think to protect the environment, to do the good social benefit, but also it's a big driver from an economic and a protect your business case perspective, because if the technology downstream changes and your product becomes less valuable because of that, you potentially are losing market share or losing revenue. So very big interest in the scope 3 from a steelmaking process. I think the other industries are probably less exposed, and I suspect probably most people in this room are copper based, and it doesn't have that same sensitivity. Taking scope 3 or taking the smelting and refining processes out, it tells quite a different story. Unfortunately, my data set is a bit messy. Nickel in there, I couldn't strip out the downstream processing, so I'll have to ignore that one. But what shows up now here is that looking at just the mining, copper, gold, lead and zinc now show a much bigger proportion of the industry's footprint. And I think that's probably where the industry in Peru is most concerned, being those are the commodities that are really coming out of this country. So I'll jump into Peru now. So what I've done here is I've stripped this down again to look at just Peru and across those 4 commodities. And again, I'm probably not telling you anything that you don't already know. Obviously, copper is the big volume game. So we see a very big footprint from copper. And this is broken down by the source of emissions. So again, no surprises, trucks and mills. So trucks, obviously, because of huge volumes of material that are being moved, and mills just because they're energy hungry pieces of equipment. So counting those 2 pieces of equipment within the Peruvian mining industry, I didn't get the numbers, but you're probably talking 70–80% of the footprint comes from those two independent areas. How does Peru compare to the world? So what I've done here is I've grabbed that same data set and grouped Peru as a country from both a total emissions perspective and an emissions intensity perspective. And what you're seeing here is probably no surprises, is total emissions from Peru in the copper space are approximately second in the world. Again, behind Chile. It's,
second in the world.
Second highest from a total, but that's really a function of the volume of copper that's produced as opposed to how it's being produced. The second one shows how it's being produced, and that's a very different story. So whilst you've got the second largest footprint, from an intensity perspective, you're in the sort of the 40 to 50th percentile. And really, if you're talking about the volume game, Chile, from an intensity perspective, is slightly better, but they have a bit of a different footprint. So Chile's overall electricity footprint is relatively smaller than Peru. And I think there are some interesting things with the, I suppose, the electricity market and the grid that's driving that difference rather than how the mines are operated. So I think the good news story in here is the very large hydro power base that Peru have, and that makes it relatively easy to get a fairly green electron into your plant. I guess the concern is, as you're looking at the recent growth of power generation, the last 20 years, gas combined cycle power stations have been filling the gap, and the hydro power stations are staying the same. And there's been very, very little penetration, as far as I can see, from wind and solar to try and come in behind and generate more of that electricity. So Peru, and again, probably no real surprises here. If you group everything into whether it's diesel or electricity, you almost see a 50-50 split, 47% electricity and diesel. The pathway for electricity is relatively clear. It may be challenging, but it's relatively clear. And that is through developers, is organised for green PPAs, build out renewable plants. You've got actually some really good resources in Peru, particularly in the solar space. Now, this is largely a function of when you can do it, based on the contracts that you may or may not have with the power suppliers that are existing. But it's a fairly clear pathway. The technology's there, the return on investments there, the business case is there. It's quite clearly achievable. The second half is a bigger challenge. So diesel in Peru, not in Peru, diesel as a general rule is great. Maybe not so much from a green perspective, but from a mining perspective, it's cheap, it's flexible, it can pretty much do everything. Whereas if you start to electrify that plant, you then have to answer a whole range of questions. What's the right technology? How do I offset battery longevity with charging time? How stable do I have to make my mines and ramps so that I can charge on the ramp? Can I look at alternatives such as conveying on the ramp? If so, what does that mean for my mine plan? All of this changes what was a very flexible and very adaptable medium, which was diesel. The other few interesting things I've got in here, and I could be wrong, but I think from an order of magnitude perspective, I'm in the right order, is if you were to look at electrifying all of the trucks that are operating in Peru right now, it's a base load of about 300 megawatts just to electrify the trucks. And if you were to supply those with green electrons, and I've just used solar as an example here, you'd need to install about 1.5 gigawatts of peak solar capacity. So it's big. And you'd also need long-term energy storage solutions. And that's on that sort of scale, battery starts to become uneconomical, and you'd have to start looking at potentially large flow batteries or even pumped hydro as an energy storage medium. The benefit Peru has is that most of the mines, if not all of the mines that I know of, are on grid. So it's easier to manage that electrical infrastructure on grid than trying to have your own energy storage and generation facilities on a self-formed microgrid. I'm not going to spend a huge amount of time on these next two slides, but I thought they were telling a similar story. So from a lead and zinc perspective, not too dissimilar. There's a new competitor in the market, or a new person in the market here, which is China, which is the very big footprint. But outside of that, quite a similar story, that Peru sits fairly high in the total emissions, but relatively low in emissions intensity. I guess the primary problem that you see there is, again, trucking is a big component of the footprint. Your lead and zinc, it's almost a replication, and there's no surprises there because of the structure of the ore bodies. Again, a very, very similar graphic. The only difference here is if you include smelting, which I have done, the zinc, is that it's pushed the electricity component slightly higher, but more or less the same problem. Big diesel footprint, big electricity footprint, clear pathway for electricity, uncertain or less certain pathway for diesel. So I think I've actually touched on a lot of these points as I was going through from an opportunities and challenges perspective. So I think fundamentally it's actually a low baseline of I don't want to call them traditional renewables, but I'll call them cheap renewables. So wind and solar effectively are cheap at somewhere around the $800 a kilowatt installed, 800 US a kilowatt. And you've got a big hydro footprint as well to give you some baseload green power. Being connected into the network makes things easier. Some of the challenges that I suppose you're seeing is an increasing presence of gas turbines, and whether or not that's going to slowly erode positions until green PPAs can be signed. So we may start to see an increasing footprint as the grid expands until mines can get onto new agreements. Opportunities and challenges in deep pits. So that presents big diesel consumption, but it also you've got big pits with stable ramps. It does give you opportunities for alternate technologies where a long shallow pit is not suitable for in-pit conveying, for example. Some of the much larger and more stable, it's called slower moving pits, can facilitate that technology at reasonable cost. I think the other point which I touched on before is from a scope 3 problem, which is much harder to control. The footprint in Peru is relatively small, so I guess the focus can be much more focused on scope 1 and scope 2. This is just a little bit of colour around the challenges, and I'll go back to diesel is easy. The default for however many years we've been mining has been, we're going to build a trucking fleet, we get a diesel fleet. It's relatively cheap. We know the infrastructure, you know how to maintain them, and it gives ultimate flexibility so the mine plan can adapt and move. And the uptime and the fueling is relatively fast. In the new world, where you're starting to look at electrification of your fleet, there is no right answer at this point. I think it's all too easy to say battery's the right answer because battery has a very efficient conversion of energy. So on a pure energy basis, say I want to have the most efficient technology, battery. Problem is, it doesn't exist yet. So you've seen the press that the trucks are getting closer. Cat's got one running around in the proving ground that you've probably all seen. Anglo's got a hydrogen truck that they're trialling in South Africa. FFI have got a hydrogen battery truck that they're trialling in WA, Western Australia, sorry. So the technology's coming, but that technology has challenges. So no one's running one of these battery trucks up a 300-meter incline out of a mine. And the challenge that brings with it is the flexibility may be lost. And so if you look at each of these technologies and you have to assess what stage the mine's in, how flexible is the mine, how much capital can I spend, can I afford to do nothing if I've got a fairly short mine life or a fairly short remaining mine life. Is hydrogen available? Have we got good resources to generate hydrogen on site? All of those complexities mean that the trucking case is no longer just we're going to go and buy a fleet of 30 797s. We now have to say, well, what's our power unit? What's our upstream infrastructure? How are we going to accommodate that in the mine plan? So from a design perspective, it makes it much more complicated. And I think that needs to be thought through on a case-by-case basis. There is no right and wrong. So that was kind of my high-level view of what's going on in the industry, and maybe I didn't actually touch on it at any great detail, but the problems that you've got here are more or less the same across the globe. So what we're seeing with all of our customers, I suppose, particularly in Australia where I'm based, it's exactly the same problem. We want green PPAs, and we want to electrify our fleet, and everything else we're kind of working on the side. But if we can solve those two problems, we get 90% of our footprint solved, and everything else will come out in the wash. I'll change tack now and talk a bit about Bechtel and what we're doing. So approximately 18 months ago, we made a strategic investment to build a Centre of Excellence. It wasn't actually called a Centre of Excellence at the time. We were a strategic investment into decarbonisation. I was asked to set that group up, and the mandate for this group is to be outwardly focused. So what we wanted to do was be able to offer services to our clients to be able to help them achieve their goals. So we could have turned around and looked inwards and said, how are we going to solve our problems, which we do need to do, but that's not the focus of our group. It was really to bolt on to an additional service to our traditional EPC and EPCM services to make sure that any of the decarbonisation needs of our projects were being met. Most interesting part of that I've seen so far has been, as we know how long projects take to go from concept or identification through to execution, we now have projects that have been essentially funded or going through the late stages of funding that have a basis that doesn't align with the corporate vision. So projects that have been developed over the last 5 years haven't adapted to the targets that the companies have set. So a typical decarbonisation target may be a 30% reduction on a 2020 baseline by 2030. Pretty well where most of the customers are at. And at the same time, a project's coming through which has diesel trucks, a traditional flow sheet, and so if you build this, you're actually going the wrong way. And so this is quite a challenging time for delivery of projects, because to go back and build all of this technology in will add cost to a project, but to not do it means we're already going backwards before we've even started meeting our commitments. So that's an interesting challenge that we're trying to get through right now. The other key point in what Bechtel's doing is in setting up a COE. We're an EPC company, typically work in the back end of engineering, delivery, handover of projects. We're trying to pull ourselves much further upstream into the study phase so that we can influence how a project looks in the early days, but using the construction and execution knowledge. One of the issues that I'm seeing is designs are being met and decarbonisation pathways are being developed for projects that don't necessarily have a very sound basis in reality. So a project will be build out the fleet, build out green electrons, do this and this and this, and it's going to cost you X dollars, and it's going to save you Y dollars over the many years because of the lower cost of energy. When you actually put the meat on the bones, that doesn't happen, because the reality is that the projects are much more complex than being estimated. And I believe that's where we can offer some real value, because we do have groups that execute renewables projects. We have groups that are doing carbon capture. We have groups that are doing hydrogen projects, and we can pull that experience all in, real life experience, and bake that into our studies and execution planning. So I'll talk about on that slide. So really high level, we've got, I won't talk about them again. The specific tools that I want to talk about, I think are quite interesting. We've developed them in-house. There are two tools that we're using on project now. One's called Carbon Comparator, and that is an optioneering tool that we take from the very early study phases, and we carry it all the way through to execution. It's a multi-variable analysis tool which allows us to build up multiple cases with different mine plans, different processing plants, different fleet. We can even get down into details and saying different contractor or a different supplier of equipment, and what's the impact of that decision. And we can have multiple scenarios going through and pick the right trade-off between capital cost, risk, and the the extra leg that I'm putting there is the emissions target. So carbon comparator is our sort of holistic, what is the life cycle emissions of this plant and what's the right risk profile for that project. Clean build is a different tool, and it's a more important tool for us in the execution phase, but it has less breadth. So imagine the project's been set, the execution plan is largely been set, scope's been set, and we use it as a workshopping tool to take to in the late feasibility stage or late feed stage to work through that strategy and say, how do we minimize emissions with the current technology on this current project now? So we build up the total execution footprint. So essentially our scope 1, scope 2, and scope 3, and our customers scope 3 because it's ours. And we say, here's our footprint of X, and we go through a series of initiatives, and we can turn them off and on, and we can turn the dial up and down, and we can see what the impact to the execution emissions properties or execution emission footprint is. And we can test that sort of live, so we can say to the project, are you prepared to do this? And they'll say yes. And we can start to turn it up and say, well, are you prepared to do that for all of your scope? And that may be, are we going to engage with a contractor who only has this piece of equipment that we know is more efficient than that piece of equipment? And the project team might say, yes, I'm prepared to do that. So we can turn that dial all the way up. And the next one might be, are you going to, we get down to kind of wrap the mic, are you prepared to pay extra for a additional thermal insulation into the cabins? Or are you prepared to use what we'd call a standard build? And they say, okay, we are prepared to pay for more insulation. We can turn that up. The calculations run through and they show that the electricity demand goes down because we're typically running off diesel currently for our projects. Our diesel usage goes down. It also then calculates how many trucks are delivering the diesel. So our scope 3 goes down and so on and so forth. And we can keep turning these dials until we get the right balance between capital cost, risk, and what's in the market right now. So there's no point in us putting all of these options on if the market can't support it. If they don't exist, we can't do it. So we need to provide pragmatic, realistic solutions to execute a project now. So really high level, I've spoken about carbon comparator before. I think the most important thing for this is we carry it through the various life cycle stages of the project, and we refine that carbon estimate as we go. So a little cartoon here that shows how we use it, and we all know how a project is developed right now. You grab the old design and you see if it fits the new plant, and if it does, you work with the client and you change a few things, but really you've got the old plant and you've just shaped it into its current shape. What that means is if you've done nothing else, you'll have the same footprint or potentially worse. So that's sort of column A. And if we say, well, this project's got to be executed in the next 5 years, we've made a commitment to be 30% lower in 5 years. What are we going to do? So we go through the process and say, these things here we can hit, these things here we can't, but we can reinvest in these areas here. So as a cartoon, we theoretically move from this point here to this point here through that early study phase. And that means that there are no surprises as the study progresses where we have to add capital later. We've actually baked that into the early study phases. We then go through, just calling this kind of the design development phase, where we sharpen the pencil like you're going from pre-feasibility to feasibility. Everything tightens up, it grows a bit, it shrinks a bit. And we use both clean build and the carbon comparator to tighten that estimate up. And then a service that we can offer. It's not necessarily something we do on all of our projects, but we talk about what's the pathway to net zero. So has the project that we built got the infrastructure in place? A perfect example would be trucking. Maybe the fleet's not there yet, but we want to make sure the transmission and distribution and upstream substation infrastructure can support the extra 50 or 60 megawatts that the plant may need to handle to run a trolley system or to run a battery charging system. So it's really about looking at what can we do now, but also what's the right pre-investment, what's the right pre-investment based on where the technology may or may not be in 5 years' time when the project's executed. Little case study here, which I thought was interesting because until I did the work, I didn't actually intuitively grab this one. So we were working on a project for a customer in Australia, Western Australia. And we used the tool to assess 3 different crushing and conveying options. And it was, without getting into details, a primary crushed ore, so a minus 230 millimetre material, about a 30-kilometre overland conveyor system with a few transfer stations, and about 30 million tonnes per annum. So not massive, but fairly sizable, sort of 5,000 tonne an hour system. And we ran the analysis on the various different options, and this big yellow bar here is power. So over the life, I think it was a 20-year life that we allowed for. Obviously, power was such a huge component, and that they were running a combined cycle gas plant for this estimate. But what shocked me was the top blue line, because this is when I talk about scope 3. And whilst it's out of our control, we can influence it. And what we did was we played around with belt speeds. And so traditional thinking in the engineering space is make it as cheap as practical, and cheap in a conveyor is run it as fast as you can. And the challenge with running it as fast as you can is wear rates at a power law. So the faster you run, the faster the belt wears out. And you've got to balance that with faster you run, the lower tensions are. So lower tensions mean less steel and less concrete. But what we found is as you slow the conveyor down, there was a little sweet spot where the life of the conveyor extended, and you weren't replacing the belt as frequently. Now, it might seem intuitive once I say it, but the actual embodied emissions of the belt itself were about 55% of the system. And that is a throwaway component. Now, depending on the ore type and depending on speed and depending on length, you may be replacing belts. I mean, short belts, you might be replacing them every 4 months. Long ones, maybe every 4 years. But over a 20-year mine life, if we get one extra life out of the belt, it meant that scope 3 footprint, which is essentially out of our control, we had some level of influence to say, let's make these decisions around belt speed that aren't purely economic. They are thinking about our scope 3 emissions. It's a little bit challenging because scope 1 and scope 2 are the ones that get directly reported, and they're the ones that people focus on. But these decisions can have a global impact. And I think it's a really good approach to start thinking holistically about where those embodied emissions are from a maintenance perspective, because they do influence it. And this client here is well on their way to replace some of their generation capacity with wind and solar. So as you can imagine, if this yellow bar starts to go to 0, the blue and the grey start to become a much bigger influence over the decision-making around emissions. I have spoken about clean belts, so I don't really want to get into too much more detail here. It's just a few screenshots of the data that comes out. I think the beauty of the system that we've got is that all of the interventions are hardwired into it. So turning them off and on, number one, it gives us a real number. So we know that we're working from, say a real number, and then I'll say X tons of emissions for a given project. And that we know if we do turn something on, we can tell within a reasonable level of accuracy that we are going to see that material benefit. So it goes away from kind of greenwashing where you can put some photovoltaics on your plant and say, hey, we've done this, to we're going to put photovoltaics on our plant because we know that's going to have an impact of 7% of our total footprint, or 10%, whatever the number is. So it means that with data, you can make informed decisions, and those informed decisions mean we can spend money in the best location possible. So this is just an example of some of the outputs that we've put on a project that we're working on now. It's a smelter, an aluminium smelter in the Middle East. And through that process, we've identified, I think it's 14 or 15 options to lower our emissions in execution. Won't sound huge if we're all targeting 30%, but what we've achieved here, or sorry, what we're planning on achieving, we haven't actually executed the project yet, is a 15% reduction on how we would have typically executed the project to how we are going to execute the project here. And they're all achievable things that we can do now. And we haven't done it yet. We're pricing those as we speak. And from that pricing exercise, we're going to say, here are the ones that sit on the left-hand side of our marginal abatement cost curve. And we're kind of thinking the big picture. I'm sure many of you here are familiar with the marginal abatement cost curves that the people are working to say how we're going to invest our hundreds of millions of dollars on our plants. We're trying to take that down to a certain level where we can say how are we going to invest $1 million on our execution strategy. So we're kind of building all of that logic down to all of the decision-making processes that we're going through now. So that, I think I've kept pretty well to time. That's really, I suppose, the summary. Was a bit of an introduction into what we're doing and a bit of an introduction into my view of views on where the industry sits. As I said, I wasn't 100% sure of what the audience was interested in, so I hope I didn't just blab on about stuff that you already know or not of interest. I can take a few questions, but I actually have a plane to run to, so I'm not going to stick around for too long, but really appreciate the opportunity that you've all given me today to present to you. So thank you.
Thank you. Muy bien, vamos a tomar algunas preguntas para Tom. ¿Preguntas? Questions? ¿Tenemos preguntas? Alex?
Do we have any questions, Alex?
Adelante.
I want to know a little bit more of how you plan this, right? But how you can control it, like the day-to-day and follow up everything. It's with that system, with the plan one?
I actually don't have a very good answer for you. I can have an answer of how we're planning on controlling it. We track our emissions right now. I'm sure everyone's going through these problems now. It's hard to track everything. What I'm trying to build, and I haven't actually got it into our systems yet, but the processes are in place, is to treat it as we do dollars. We're implementing a system where if we have a change to a strategy or a change to the design, we're trending that as we would trend a budget or a schedule movement. The tracking requirement comes down to various different things, and I think that there's you can't get to the level of detail that I can get to in here and track everything because it's far too challenging. But we're building it into our contracts to make sure that the contractors are supplying the information, and then we're using key metrics in that contract to build into our dashboards. So what we'll do is we'll draw parallels between the primary emission sources as estimated, and we'll track against those. But we're not going to track against how many toilet flushes we do. But yeah, it's treating it like we do dollars is probably the easiest way to think. And that's how we can get to an EPC.
¿Más preguntas? Ana
Any
Rosa.
other questions?
Yo tengo una pregunta.
I do
Tom.
have a question, Tom.
Como escuela metida en
As a
educación,
school,
nosotros queríamos saber cómo
So we
son
would
las capacidades de los gerentes para
what
entender
are the capacities of our managers?
su mindset de priorizar estos temas, a pesar
How
que
can they prioritize these topics?
y tomar decisiones adecuadas que
They
favorezcan
can make right decisions
al actor en el diseño desde el inicio del
in the
proyecto.
design since the start of the project.
Y también el tema de la fuerza laboral, es
And
decir,
also about,
sus capacidades de
of
ingenieros,
course, about the capacities of engineers
poder luego aplicar estos temas
to then
ya
apply
en la exploración, en la
these
explotación de la
topics
mina,
in
cuando
the
está operando.
exploitation of the mine.
I apologize. I was trying to listen to you in Spanish and I shouldn't have done that. And I missed the English question.
Ana Rosa said, how do you work with the clients in order to put the ideas of mitigating CO2 emissions in the, in the high executives of the company, and how do you help companies to manage that people, workers in the company, also adopt this kind of mitigation programs?
I think the first half of that question is really easy. The executive are all over this. that they are standing up the top saying, we have to do this, here are the targets, that ship has already sailed, and as far as I can see, we're all on it and everyone's moving in the same direction. The workers is a much bigger challenge. And that was kind of the point that I was making before around a project has a certain trajectory and people don't want to change that trajectory, even if it's already missing target. And to be honest, I'm having that challenge internally and externally because we're a bunch of engineers who put our blinkers on and want to head to the end. Again, I'm going to give you a very good answer. The best thing that I can do is internally, I'm forcing this through kind of a bottom-up approach onto our projects, but I'm also connected into our executive who are pushing from the top down, and that push from the top down helps because when the senior leadership on our side start to get alignment from the next level down and the next level down, it pushes through. But it is really challenging to get this incorporated. We have several projects who have champions that want to drive that, and that makes my job easy. So this example that I gave you, the project manager, he's an advocate, and he will say, I want this, and he kind of pulls me in and makes sure that the drive that I'm giving him is driven into the whole team.
So you mean that decarbonization in mining requires a lot of leadership?
Absolutely. Yeah. I think as like most things, the culture that's set at a senior level pulls through to the team. So I think corporate we're quite good right now, but I think at a PM type level and a project lead level, we're probably not there yet. And that's, I think, largely due with so many of us have taken a project for many years and we get beaten up on dollars and schedule. And then this is hard if it doesn't add value from a pure dollars and schedule perspective. That's the challenge that we've got in, I think, this transitional zone in the last, say, 3 or 4 years where this is elevated. It's the projects haven't quite caught up to a corporate level.
You mentioned about leadership in project managers in order to address all these concerns, but what is your opinion about the tendencies that we have right now, meaning balancing the environmental concerns with the industries like mining, essential role in providing raw materials to satisfy different sectors in the world. So do you think that we are getting into that path, into balancing that in favor of this objective?
I think we're actually talking about this at lunch, is mining has a pretty bad PR. Right. We need the minerals. We need, if we want to change our electrical infrastructure, if we want to change our mobility infrastructure, we need the minerals. So that has to happen. And if we do nothing, we're worse off than building the mines. Unfortunately, or fortunately probably, the mines need to lead by example as well. So we can't just extract the minerals, we have to at least demonstrate that we're heading in the right direction. But my view is we need to do this with a pragmatic approach. So we can't just say we're going to flick the switch and we're all going to be green and the mining industry is going to change overnight. That's not going to happen. So we need to be able to demonstrate projects that are moving the needle, and each time we execute one of these, we get better. And all brownfields modifications, they show that we're improving on our past, I wouldn't say problems, but our past, we're improving. But pragmatically, we're going to have diesel trucks for a long time, and that's okay. But we need to do that, otherwise we won't have the minerals to build out the infrastructure to build the electric trucks. So it's I think it makes sense to have a long-term transition plan. My opinion is we've all made these commitments. I think the 2030 commitments are going to come and go, and a lot of us are going to miss them. I think we've probably already starting to come to the realization that we're going to miss our 2030 targets. And I think that's okay as well. I think it's better to shoot high and miss it than not try. So it's okay, but it's not. It doesn't mean we don't have to keep pushing, and we have to be relentless in that push. Otherwise, we'll all kind of just go back into our comfort zones. But we will miss the target. is my view.
Carlos.
Yo tengo una pregunta para la audiencia, porque si piensan que él va a llegar al aeropuerto en 45 minutos y se
He's not going to do that. Not be able to do that.
Sí, entonces,
Yes.
I need to kidnap you and take you to the taxi. Otherwise, we will miss the plane.
Muchísimas gracias a todos. Thank you all for participating in this seminar.